order reaction. And one more question also we had done. So let's see if just so what are the questions I had done under that. I'll take it over here. It already is there. Okay. 75%. This question is different, man. This question is different. And this one is this also is different. And first question also is different. First question also is different only. This first question is related to zero order reaction. Second question is related to the first order reaction. And third question is related to half-life period and first order reaction. Half-life period and first order reaction.
Yeah, sir, we did this problem. I was there when you did we did these problems together on this.
Yes, yes, ma. Now the next question is my question is here. What is the next question means? They had given some data. They had given some data. Time is 100 minutes. They had given total pressure 0.5 and second experiment 0.512. Okay. So finally, let us see. So we'll solve this question. Solve this question. I think so. This formula we derived. We didn't do the question based on this one. Okay. Now I'm going to write the question here. What is the question we have to write means here? Question number 4. Question number 4. I think so it is JEE level question. It is a JEE level question. The following data were obtained. The following data were obtained. Data were obtained during the first order thermal decomposition of during the first order the thermal decomposition of first order the thermal decomposition of N2O5 at constant volume okay here. So 2 moles of the N2O5 gives rise 4 moles of 2 moles of 2 moles of N2O4 plus 1 mole of the oxygen gas. 1 mole of the oxygen gas. For that one, they had given some data. So what is the data they had given means here? At time t, at t is equal to 0. Okay. The initial concentration at t is equal to 0. Initial concentration of the N2O5 they had given as a 0.5 atmosphere. 0.5 atmosphere. Sorry, 0.5 atmosphere. Yeah. At time 0, the total pressure. This one is time 0. The total pressure 0.5 is here. Total pressure. Okay. Total pressure they are given as a 0.5. And the second condition at T is equal to 100. Okay. So the total pressure is 0.512. It is the first experiment. It is the second experiment. So this is the data they had given. This is the data they had given. And calculate the rate constant. Calculate the rate constant. Calculate rate constant. Calculate rate constant. How we can calculate the rate constant? Which formula we can use to calculate the rate constant in this one? Hi Aditi, Kathy. Reading all. How many days you got the holidays, all of you?
3 days for me, sir.
3 days per week. So when to when, ma? Ritu?
13 to 17, sir. Yeah, 4 days.
4 days. 13 to 17. That means Sunday also holiday, yeah.
Yeah, sir.
13th means tomorrow. Tomorrow is the last working day.
Yeah, 14th is Sunday, and then 15th, 16th, and 17th.
17th. 14th, 15th, 16th, 17th. Okay. Next, Aditi. Aditi, what about your holidays? Aditi is not responding. Kathy?
Sir, I'm not going to college, sir. I don't know.
You don't know, okay. If you don't miss, then can I
Sir,
take it?
you were asking something?
Yes, Aditi. So you got Pongal vacation holidays or not?
Yes, sir.
How many days on holidays are there?
So from 13 to 17.
From 13 to 17. If you don't mind, I'm not going anywhere. Okay. So if you are ready, means I can take some extra classes to you in this
So
Pongal
that's fine
vacation.
with me.
What about Ritu? Ritu, what about you?
Yeah, sir. Totally fine.
Kathy?
Yeah, sir, I'm fine with it.
Okay. Except festival day. So remaining days are the remaining 3 days are there. Okay. For me also same holidays. 14, 15, 16, 17, I'm having holidays. So this time I'm not going home. Okay. So that's why I'm planning to take some additional classes. With your concern, I can take daily 2 hours class.
So can you keep it in mornings? Because like I'll be going out in evening every day. So
Sure.
in morning
What
around 11, 10 to
Sure.
11.
10
Thank you,
to
sir.
after 10 o'clock, no problem. What about Ritu?
Yeah, sir. I'm fine with anything. I'm not doing anything, not going anywhere at my house.
Uh, and Kathy, is it okay for you? Can I start the
Yes,
class at 10 o'clock?
yes, sir.
Okay. So then in vacation time, I'm going to take the 10 to 12 class. Okay. So next, so I'm going to start the organic chemistry for you. Because of 2 chapters, we completed the physical, na? We completed 2 chapters. So what are the chapters we completed here? So one is the solutions we completed, and another one is the chemical kinetics we are going to be completed. First, I'll complete the chemical kinetics. Okay. So then after completing the chemical kinetics, we'll go for the organic chemistry. Is it okay for you all?
Yes, sir.
Then fine, man. Okay. Now, so let us see ma here. So I gave some questions. What is the question mean? The following data were obtained during the first order thermal decomposition of the N2O5 at constant volume. Okay. So here they had given some options. Here they had given chemical reaction and they're asking calculate the rate constant. Calculate the rate constant. How we can calculate the rate constant for this reaction? So this one T is equal to 0 means it is the initial pressure. Okay. And T is equal to at a T time T100. So it gives us a final pressure. Okay. So the question is related to we had derived some formula. No? So what is the formula we derived? Do you have any idea about
Is
this one?
this K is equal to 2.303 by T log Pi by 2 Pi minus Pt. Should we use this one?
2pi minus pt.
Pt.
Exactly, Ritu. It is the correct formula only. Okay, it is correct formula only. Okay, and we have to know the final pressure now. Okay, so we have to know the final pressure at a t time. At a t time, we have to know the final pressure. How we can calculate the final pressure?
At 2 Pi minus.
Hmm. 2pi.
Isn't the 2 Pi minus Pt the final pressure, sir?
But here small change is then in reaction. So in this one, total pressure will get as a different formula here. So final pressure you will get as some different formula. Actually, it is correct only, but according to the chemical equation, it is different. It is that. According to the chemical equation, we are having the different formula. So first we have to derive the formula. How we can derive the formula means here, once you check it out here. So what is the formula means here? So what is the formula they had given means directly I'll write the formula. I don't want to waste time. In this one, the final formula is they had given as is equal to PT minus of 0.5. But otherwise, can I derive the equation? First, let us see. Anyway, we'll derive, otherwise you'll get the confusion here. Okay. So as 2 moles of the N2O5 gives rise to 2 moles of the N2O4 plus O2. In this one, initial pressure we had taken as a 0.5. Okay. So final pressure it forms as a 2x and it forms as a x moles of the oxygen gas is formed. Okay. And at T time, T is equal to 100. At T is equal to 100, how we can write means here 0.5 minus 2x. 0.5 minus 2x and 2x and x. Actually, initial pressure means this also will get as a 0, 0 only. There is no value for the products at initial time. Now it is clarity. Okay. So at initial time here, so 0.5 means it has a 0 and 0. And after T at T100, the pressure you will get as a 2x and x. How we can calculate the total pressure? According to the Dalton's law, sum of the partial pressures only now. It is sum of the partial pressures means how we can write 0.5 minus 2x plus x. In this one, 2x minus 2x is going to be cancelled. According to that one, how we can get 0.5 plus x. And x is equal to 0.5 minus pt. 0.5 minus pt you will get by. Okay, 0.5 minus pt you will get here. So same equation, if you apply in this one here, x value for applying the equation at initial pressure, x value can apply in this one here. Okay, if you apply means here, so 0.5 minus of 2x. What is the 2x value? Here 2 into 0.5 minus pt. If you simplify this one means, so what you will get, 0.5 minus 2 it is there. So minus 2 means you will get as a minus 1 only na?
1 minus PT. 1 minus 2 PT, sir.
One second. Here I wrote the formula is wrong now. Here onwards. The x value we have to find out. How we can get the x value? Every time I'm doing mistake here only. If 0.5 it comes this side means pt minus 0.5 na? X is equal to pt minus 0.5. Is that clear?
Yes, sir.
Okay, x value I wrote so wrongly here. So then what is the formula? 0.5 minus of 2 into pt. Okay, x value. So right means here pt minus 0.5. Now if we simplify that one means how much we'll get? 0.5 minus 2 into 2 pt. So minus 2 in minus into minus it becomes as a plus and 0.5 into 2. 0.5 into 2 means you will get as a 1 only na. Hence you will get as a 1.5 here. How much will get ma? So 0.5 plus 1. 0.5 plus 1 means how much will get? 1.5 minus 2 pt. So this is the final value. Which one here? So final pressure. So what is the final pressure means that we can write here. In place of 2 pi minus pt, what we can write? We can write as a 1.5 minus 2 pt. In this one, we know the pt value. What is the pt value they had given in the question? 0.512. Now we can substitute the formula here. So how we can write the formula? K is equal to 2.303 divided by T log of P initial by 1.5 minus 2 pt. 1.5 minus 2 pt. Already pt value they had given. Okay, so what is the pt value they had given?
0.512.
0.51 0.512 mark. Okay, pt values they had given as 0.512. Okay, now we can take it out here. So 2.303 divided by t value. T value how much they had given? 100. Okay, log of initial value 0.5 divided by 1.5 minus 2 into 0.051. Okay, 2 into 0.051. Now if we simplify means you will get the answer now. So can you simplify this one here? All of you can you simplify and tell me the answer?
Sir, 0.5 by 1.5 minus 2 into 0.512. If you simplify that, the value you get it as 0.488. 488. I still have to simplify it. 2.303 by 100.
So once you check it out here, if we simplify that one with 0.5 divided by 1.5 minus of 2 into 0.05. 2 into 0.05 means how much we get? So 2.303 divided by 100 log 0.5 divided by 1.5 minus this one. What is the, if you multiply by means what is the value you will get?
1.024.
Into 2. 2 ones 2 here. 2 5s 10 and 0.102 0.102 we got the value. Is it correct? Okay. And if we subtract from 1.5, 0.500 and 0.102. 102 means 8, 0 and 4 it will be the 3, 1.308. 308. Actually, they had given 0.4761. But it's not, I think so. It's not the 0.051. It is 0. Much I wrote here? 0.51.
So the answer will be 1.024. You have to subtract it with 1.5.
1.5. So if you subtract with the 1.5 means here, answer is you will get as here. So what is the answer they had given means 0.476. 0.476.
0.4. Yeah, sir, yeah. Same
Okay.
thing.
So even I got the same thing.
Totally, if you simplify that one means you will get the answer is 4.98. 4.98 into 10 power minus 4 seconds. Okay, second inverse. So this is the final answer. 4.98 into 10 power minus 4 second inverse.
So how will we take the log value in this as the answer to be like in decimal?
But
Yes,
decimal and total means if you divided with one here. So 0.5 divided by rough value we can take as a 0.5 divided by 0.476 means how much we're getting? Now only I'll tell you here. Okay, 0.5 divided by 0.476 mark. So you will get as a 1.05 mark. 1.050 you got here. Log of 1.050. You will get as 0.17. Log of 1.050. Second, check it out 1 second. 0.5. Sorry, you will get as a 0.0211 mark. Actually, logarithm values they'll give in the examination only. Okay, don't get confused here. Log values and all na. If you go for the JEE level examination, means compulsory in question only they will mention. In question only they will mention.
What
Okay.
about NEET, sir?
Whatever the value it is that they'll mention in the question only. Okay. So we don't have any problem if they mention in the log values means. Okay, but simple decimal values are there na, log 2, log 3 and all. That you have to by heart only. That they won't give. What are the decimal answer and all you are getting for that only they will give in the examination part. Now you are asking, sir, what is the log value of the 0.476 means here? That I can't say. Okay, then we have to do the calculation only. You got the point, ma? Ritu? You got the point or not?
Yeah, sir, got this. I was just doing this calculation.
Okay. Yeah, so otherwise I can give the log 0.5 value. Sir, what is the log 0.5 value means I can give here to make you clarity without getting the confusion. Log 0.5 value is equal to 0. Minus of 0.3010 minus of 0.30. So because of your getting confusion, na, log of 0.5 value is equal to minus of 0.3010. Okay. Now log of 0.476 value. So 0.46 value is they had given as a log of 0.476 value is they had given as a minus of 0.3223 mark. This much I can help you. This much I can help you now here. But in examination they won't give all these things. JEE examination means compulsory they'll give the difficulty value means compulsory they'll mention in the question only. Okay. Now if
Sir,
you substitute
do they give log values in NEET exam also?
NEET examination also sometimes they'll give ma. That is only I'm telling now. If like these questions, if you like these answers, if you got me, definitely they'll give. But simple answers easily in NEET exam, what happened na? So derivation calculation part is very easy. Simplification part is very easy. Simple numbers only he will give. Multiplication division is very easy in the NEET while comparing the JEE. Because of JEE, they are giving us more time. But NEET, we don't have that much of time. Hardly 40 seconds, we have to complete one question, 40 to 50 seconds. And numericals also, it is very less. You're getting hardly 7 numericals, 7 to 8. So this time, we can expect more number of numericals. Because of syllabus is reduced, na? Got the clarity?
Yeah, sir.
Got the clarity, Ritu? So better to focus on the calculation part also. Calculations are very, very important. Okay. Now that is what I'm checking here. So one more question. So one more question it is there, ma. If you finish means. Shall I go for the one more question? I think so this one you are able to do. So second question. This another question means here. One more question I'm going to be using here. Show that the first order reaction time required for the completion of 99.9% is 10 times of the half-life period of the reaction. Okay, it is also derivation only. Show that the first order reaction, show that the first order reaction, the time required for time required for completion of 99.9 percentage 99.9 percentage is 10 times of half-life reaction half-life of reaction okay. So any guess in this one? Aditi, Ritu, Kathy, how we can simplify this question? Samhita also logged in, na? Very good.
So the rate constant formula K is equal to 2.303 by T.
Rate constant they didn't give namma. Ritu. How we can simplify this one? They didn't give the time to get as a rate constant value. How we can find out the rate constant?
Sir, can we use half-life formula?
Very good, Kathy. First, we have to use in this one first step. What is the first step means here? First, we have to use as a half-life period formula to find out the rate constant. So because of T of value already they had given. T of is equal to how much they had given here? So 10 times of the okay, ma. 10 times of the half-life period, ma. So T of also they didn't give, ma. T of also they didn't give. If you take the T of means what you can write? 0.693 divided by K. 0.693 divided by K. So that means according to that one K, we can use the K, we can write as a 0.693 divided by T of, we can write a very good, Kathy. Guessing is correct only. Okay. So rate constant, we can write as a K is equal to 0.693 divided by T of. Now you got it as a rate constant. By knowing the rate constant, we can derive the time. We can derive the time required for the completion of the 99.9 percentage. Okay. Now how we can write here formula? Ritu, K is equal to 2.303 divided by T log of initial concentration by final concentration. Okay. And to simplify this one, T they're asking. T 99.9 percentage. T 99.9 percentage is equal to 2.303 divided by T is this one K. What is the K value? What is the K value we got?
0.693 by T of.
Yeah. So 0.693 divided by T of. 0.693 divided by T of and log of initial concentration. How much it is there initial concentration? 100%. And what is the final concentration? 100 minus
99.9.
99.9. 99.9 means how much will get ma? So we'll get as a 1. So this one 0, 0. That means 0.1 na? We get as a 0.1. So 0.1 also we can write as a 1 by 10. We can write or not? We can write or not, ma?
Yes, sir.
Okay, 0 point also we can write as a 1 by 10 value. So if it is 1 by 10 directly, I'm writing as a 1 by 10 here to make it clarity here. 1 by 10. If we simplify all this one means, how we can write 2.303 divided by 0.693 into T of log of ma. So log of 10 power here. So if 10 it comes to the numerator means it becomes as a 10 power 3. Okay. If 10 it becomes to the numerator part means it becomes as a 10 power 3. If it becomes as a 10 power 3 means so log a power m value. Log a power m value how we can write? Any one of you? M log A na?
So 3 log 10.
3 log 10. Very good, ma. So 2.303 divided by. So how you got as a 0.693, ma? Any one of you having idea? Any one of?
It's the formula, na sir.
It's a formula only, ma. So actually, by derivation of the half-life period, so there you got as here
Log 2 into
2.303 into log 2. Log 2
log 2.
value is 0.3010.
10.
3010. If you multiply with this one means here, then only you will get as a 0.693 is the value. Okay. So to simplification, why I am asking this concept means to make you simplification is easy. Okay. Now in place of 0.693, can I write this value also now? 2.303 into 0.3 only I am writing. Here T of, so T of 3 log 10, log 10 value 1, 3 into 1. Now we can simplify. 2.303, 2.303 is going to be cancelled and 3 divided by 0.3. That means 3 ones, 3 ones. You got as 0.1. So T of divided by 0.1. T of divided by 0.1 means if we simplify that one means how much will get? 10 T of we can write now. 10 T of we can write or not?
Yes, sir.
Okay, so based on the one, so based on the derivation, what we can say? So T 99.9 percentage, T 99.9 percentage is equal to 10 T of, is equal to 10 T of. Okay, for that one, some logic is there. Okay, sir, we applied the formula. We
Didn't they
applied.
already give that in question that the time required for completion of 99.9% is 10 times the half-life of the reaction?
Yes, ma'am. We are deriving that we are showing proof. Whether it is correct or not, that we are showing as a proof, my here.
Oh, yeah, sir. I forgot that the question was showed.
So because of show that it is there. So sometime how they're asking the question means here, let us see some questions are there based on this one. So this also we can do in short form. How we can do the short form means here, what is the half-life period of the first order reaction? So T of is equal to 0.693 divided by K only now. That means half-life period is depends upon the initial concentration or not, ma? That is T of is depends upon the concentration of the reactant or independent on the concentration of the reactant. Aditi,
Dependent, sir.
independent, ma. It is independent on the molar concentration of the reactant. So we can easily simplify that one. Sir, how we can see means here for completion of the 100 to 50%. 100 to 50%. It takes as the same time. There is no difference in the time. Okay, there is no difference in the time. For example, in the completion of 100 to 50%, if it is taken T off, then it is conversion in the 25%, that means 75%. In the conversion of the 100 to 75% means how much time it takes means 2 T off. 2 T off. If you convert into the 87.5%, okay, that means 12.5%. 12.5%. Again, in this one, 25 in 25, what is the percentage here? 50% means 12.5 only now.
Yes,
Okay. In the conversion of the 25 to 12.5% also it takes as a T of time only. Okay. And from 12.5 to 6.2 you will get a 6.25. In half of 12.5 E also we can consider it as a again T of only. Now let us see how they're asking the question means here how much time it is required in the completion of the 75% of the reaction with respect to the half-life period of the first order reaction. So can I repeat the question once again here? How much time it is required for the completion of 75% of the reaction? 75% of the completion of the reaction with respect to half-life period. respect to half-life period. Half-life period. Okay, so easily how we can identify options they had given us a 3T of 4T of, okay, so 2T of and T of ma. How we can identify? Just you can check it out. First 100 to 50. Here we completed the 50% and 50 plus 25, 75% now. In the completion of the 75% of the reaction, how much time we had taken means 2T of. Okay, it is 2T of T of T of. So T of T of plus means you will get as a 2T of. So what is the answer means here? 2T of. Sir, when we can take as 3T of means in the completion of the 87%, 87.5% of the reaction is completed in 3T of time. Okay. Again, for that one only if you add some 6.25%, 6.25% means how much it becomes? How much it becomes, pa? It is shortcut actually. For this kind of questions, it is a shortcut. Because of sir, how you are telling that means, so time is independent on the molar concentration of the reactant. So when you are converting into from 100 to 50% also it takes same time only. For example, it is completed some 30 minutes. It is completed in 30 minutes. In the conversion of 50 to 25 also it takes 30 minutes only. Or from 25 to 12.5% it takes us a 30 minutes time only. Time is not going to be changed. Because of time is independent on the molar concentration of the reactant. Okay. So then we will do one thing. So directly MCQ questions we will do based on this concept. V2. All of you.
Yeah, sir.
Shall we do some MCQ questions in the next class?
Yes.
So until here, all of you understood now?
Yeah, sir.
So I'll do one thing. Today I'm going to forward some questions to you, MCQ questions. First you practice. If you won't get answers means tomorrow in class we will discuss all that questions. Okay?
Okay, sir.
Yes, sir.
So today only I'm going to forward the assignment. But everyone you have to practice. Right? Then we will continue in the next class.
Thank you, sir. Thank you, sir.
Welcome, all of you welcome.